Thank you, Rich. Thank you for the nice introduction. Thanks, everyone, for coming. Super excited. See some familiar faces from KubeCon. I think you were at the TNS panel last time as well, right? Yeah, a whole bunch of folks. Pretty cool. My CTO and co-founder, Fabian, is gonna, he's right here. He's gonna do a little demo and show some cool, tips and tricks with vCluster and, give you some hands-on experience with it. When you ask a company, have you adopted Kubernetes? And they answer with yes, that typically means that maybe 20 people, maybe 50 people have direct access to something like of multi-tenancy is because before we started vCluster, we were operating multi-tenant clusters ourselves, and we were really struggling with that balance between giving cloud providers have told them just spin up another EKS cluster, right? That's essentially the solution, right? The team needs a cluster, you spin up a new cluster. That is very, very costly, though. I mean, it's great for the cloud provider, obviously, but it's really, really expensive. It's the same way as if you're just handing out VMs, but actually worse because you're handing out sets of VMs to everybody, right? And in the worst case, there's also some auto-scaling involved. Nobody really knows what's running inside of there. If you hand out a single VM, it's much easier to understand, what is running in there. It's still difficult, but if you're handing out a Kubernetes cluster, it's even more challenging to keep track of those things. So it's really, really hard to manage that large number of clusters. So why don't we just use Namespace instead? Namespaces, as you can see here in this little comparison, have some pretty drastic disadvantages. The first thing is they're not as isolated as separate clusters, obviously, right? If I give someone access to a namespace, I have to set up things like network policies, obviously RBAC, I have to set up a lot of things to actually restrict that user to that single namespace. And that's obviously a lot of work versus when I have a separate cluster, I get these benefits pretty much out of the box by giving them, their own cluster. And then at the same time, the access you give to the tenant is very limited with the namespace versus when you give them a cluster, they have full autonomy. But namespaces have some really attractive benefits. They're a lot cheaper. It's easier to share resources. Just think about really basic things like monitoring a logging stack, like an ingress controller, right? Do you really want each individual team to have their own, like a 5-person team, right? Should they have their own ingress controller? Who's going to maintain that? Do they need a separate IP address and domain for that, right? There's a lot of things involved in this topic. When you're using namespaces, well, you can use a single ingress controller and just have the traffic routed in that same cluster. It's you have it out of the box, right? And then the overhead is obviously much lower because each Kubernetes cluster has this, control plane, has a lot of things that you need to run there, like a storage layer, networking, right? You have different tooling installed. You may have things like a policy agent to enforce certain things in your cluster. Well, if you have 1,000 clusters, now you have to run that stack 1,000 times, right? So obviously there's a lot of overhead. If you have namespaces, you can consolidate that to, obviously not one cluster when you're a big company, but maybe, just 10 instead of 1,000, right? But again, it's really difficult to isolate users with namespaces, and it's really restrictive in terms of access when you're using namespaces. So it kind of looks like we could combine these benefits somehow, right, and try to find something in the middle. And that's actually what we're trying to do, getting the best of both worlds. With vCluster, we're trying to create a system that creates very strong isolation, similarly strong than separate clusters, while giving the tenant their own individual Kubernetes cluster, but at the same time running these individual Kubernetes clusters on the same shared Kubernetes cluster. So we have one Kubernetes cluster that runs little virtual Kubernetes clusters on top of it, so we can combine the benefits of both worlds. When I gave this talk originally at KubeCon in LA last year, I recorded this little video and asked the audience, what is a namespace? And this is what the Kubernetes documentation showed back then. Kubernetes supports multiple virtual clusters, which was really funny. I just found that out when I was preparing for this talk. Backed by the same physical clusters, these virtual clusters are called namespaces. And I actually pointed out that's a pretty terrible definition of what a namespace is in Kubernetes. And we had this little, kind of raffle thing where we told people, hey, if you fix this, we're going to send you a swag box, right? Whoever gets the PR merge to fix this. And luckily, this is not the definition anymore. If you look at the docs today, they're a lot more extensive, which is definitely great. But they're also a lot more accurate. What it states here is in Kubernetes, namespaces provides a mechanism for isolating groups of resources within a single cluster. Yeah, I would probably put my name under that sentence, right? And then it's really really great that they also make that differentiation, just like I mentioned in that KubeCon talk, and we're going to see that in a second. There are namespaced resources like deployment, service, etc. And then there are cluster-wide resources which cannot be put in a namespace, like storage class, node, persistent volume, etc. And then the other section that they added here is also really great. It's actually explaining what the use cases for namespaces are. And it even says here, namespaces in the very bottom are a way to divide a cluster between multiple users, which is kind of the core use case we're going after with vCluster. So definitely good job on everybody who worked on this over the past 10 months since I gave this talk. I would definitely argue namespaces are not virtual clusters because namespaces are not clusters, so they cannot be virtual clusters. Namespaces provide just a scope for names, right? And this was actually a quote from further down in the documentation, way further down. Glad that that got moved up a little bit. And not all objects are inside a namespace. They're cluster-wide resource, and that's actually what makes a cluster. I think a cluster has these resources and hosts namespaces versus namespaces just like a storage bucket for certain resources. And you can actually tell Kubernetes to give you a list of all the resources that are namespaced and resources that are cluster-wide by running these two kubectl commands. The idea of a virtual cluster is now to run a control plane inside a container inside a namespace. So what is a control plane? We all know that's an API server. We have a data store that stores our deployment services, namespaces, whatever objects we create in Kubernetes. By default, that's etcd. If you have things like K3s, that may be SQLite and more lightweight. And we typically have a controller manager, which controls our replica sets, etc. Then we have a scheduler that actually schedules things to our different nodes in the cluster. And then we have workloads running on top of that that get launched through our control plane. And inside those workloads, we have namespaces. And these namespaces typically host things like pods, right? We're all familiar with that construct. The idea of a virtual cluster now is instead of talking to the API server of the real cluster, we're actually going to just launch another control plane right here inside a namespace of the Kubernetes cluster. And that means we have a second API server. And instead of talking to the real API server of your EKS cluster, we're actually talking to this API server up here now. That means it feels to us like we're talking to a fully fledged cluster, but we're actually just talking to a service and a pod that runs inside a namespace. So let's call that namespace host namespace because it's hosting our virtual cluster. We typically have a stateful set running in here. We have a service, regular Kubernetes service, right? If you run vcluster create, our CLI essentially just installs a Helm chart into your cluster, which launches the service and that stateful set. That stateful set creates a pod in the easiest case that has an API server and a controller manager bundled. In the easiest case, that's K3s, same binary, same container. And then we have a data store attached where we're actually storing the state of this virtual cluster because the state of our virtual cluster is different from the state of our physical cluster, right? And that's the core piece of what makes the virtual cluster so powerful because we have that isolation of the data store. And then, in the easiest, most lightweight case that you can run vCluster with, you run it with K3s, and you have a SQLite database, basically just a single file, right, inside that container. And you put that in a persistent volume or not, right? And then it's a truly ephemeral virtual cluster, right? If the pod's gone, you have a blank new cluster, right, if it gets restarted. And then the only thing that the virtual cluster doesn't have in terms of control plane is the scheduler. Because the virtual cluster doesn't directly schedule on nodes. There are no nodes, directly registering, and the scheduler is like, oh, we gotta, schedule things to these nodes. Instead, we have a syncer. And what the syncer does is it essentially talks to the virtual cluster's API server as well as the underlying cluster's API server. And then it just copies objects down and up, right? It keeps the state in sync. vCluster is a certified Kubernetes distro, which is kind of funny because we're running distros inside of vCluster as well, right? So we got to make sure that the syncer as the one object that we're actually not using from any of these distros, right? That the syncer does the same thing as a scheduler would do in an EKS cluster if you want to support EKS distro, or K3s scheduler if you want to support K3s, right? That's literally what we are spending most of our time on, or what actually Fabian is spending most of his time on, to make that work. So we can stay a certified distro. Right now, for the actual API server, for the control plane itself, we're supporting K3s, we're supporting vanilla Kubernetes, we're supporting K0s, Mirantis' lightweight distro, and we're supporting EKS as well. And we're looking into OpenShift right now, but it may still take a couple of months. It's a little bit more of a beast to kind of put into a container. Yeah, that's how a virtual cluster looks architecturally. How do we actually work with the virtual cluster, and what happens under the hood? What does the syncer do? That's the really interesting part of this talk. So when I'm creating a namespace NS1 now, right? again, the virtual cluster runs in our EKS cluster inside the host namespace as a pod. And we're talking, that's highlighted by this arrow here, to the virtual cluster's API server. You can do it via port forwarding to that pod, or you can set up an ingress to that service that the virtual cluster has, right? But no matter how you're connecting to the virtual cluster, if you're creating this namespace NS1, it effectively just writes an entry to the data store, right? So we now have in our SQLite, if we're using K3s with SQLite in vCluster, we just have that entry, hey, there's an NS1 namespace. That's it, nothing else happened, right? Nothing in the underlying cluster happened as well. In the underlying cluster, we only have that host namespace, and obviously, you know, the folding cube system and stuff like that, but there's no namespace NS1. It only exists in the virtual cluster. And then we can go ahead and launch in Nginx deployment, for example, kubectl create deployment Nginx deploy. We're launching it to that NS1 namespace. And we can define the image as Nginx and say replica number should be 2, right? What happens when I run this command against the virtual cluster's API server is that we're creating another entry in that SQLite database, right? That's all that happens, right? And usually now, the controller manager in a Kubernetes cluster sees, okay, we have replica number 2 for this deployment, so we actually need to create 2 pods, right? Creating those 2 pods, again, is just an entry in the data store. Nothing else happens, right? The magic actually happens when now the scheduler comes in and says like, oh, there are 2 pods that need to be launched on a node. I gotta, you know, hand them over. The kubelet needs to start them. I need to schedule them on one of our nodes. And that's where the syncer comes in. So we essentially go ahead and copy these pods down to the underlying namespace. And you know, in the underlying namespace, if we're connecting to the real EKS cluster, right, that we're using now, and we would list the pods, we would actually see the vCluster pod and the 2 other pods. We don't see the deployment of our Nginx. We don't see the namespace of our Nginx deployment, but we do see the pods. And then the real clusters, you know, the real cluster would actually schedule these pods and start them, and then the syncer would sync the status up again inside the virtual cluster, so that inside the virtual cluster you feel like, oh, those pods have now been started, or there's image pullback off, or, you know, anything that you need in terms of status. Obviously, there's the problem that we are mapping to a single host namespace in the underlying cluster, but we can have different namespaces in the virtual cluster. We can have NS1 and NS2, and both of them have Nginx pod 1 and Nginx pod 2. Obviously, if the syncer would both sync them down and just copy them, that would be a problem, right? We would overwrite things. That's why we're actually rewriting things to prevent collisions. So we are appending the name of the namespace. So we see on the left-hand side NS1, and we see Nginx pod 1 and pod 2 would be translated to Nginx pod 1-x-NS1, because that's the virtual cluster's namespace where this pod comes from. And then we also append the name of the virtual cluster, because it is even possible to run multiple virtual clusters in the same namespace of the underlying, you know, physical cluster. We could even run virtual clusters inside of virtual clusters, and then, you know, that gets even crazier. So there's a lot of logic in this syncer component. And the syncer really only needs to sync what is needed to run the pod, so only low-level resources. And that's the benefit of the virtual cluster. Inside the virtual cluster, I can have all kinds of crazy resources, deployments. I can create custom resources, right? I can create pretty much anything, and that doesn't ever reach the underlying cluster. Only what's actually needed to launch that pod. So that is the pod itself as a resource, as we saw rewritten a little bit. Plus, for example, if a config map is mounted in the pod, we got to copy that config map as well, potentially rename that as well, rename it in the pod spec, right? So that the references match up. Same for mounted secrets, but also not all secrets, only the ones that are actually needed to launch a pod. Same for persistent volumes and volume claims. What we're also doing is syncing services so that you can do DNS-based communication. And that means inside a pod of your virtual cluster, you can talk to a service inside your virtual clusters out of the box, you don't need to change anything, right? Your usual Kubernetes way of doing things with cluster internal DNS is going to work with vCluster as well. That's why we're syncing services. And then ingress sync is something that that you don't need, obviously, to launch a pod and to get cluster internal networking working, but it's something that we have as a pretty easy like true false flag, because a lot of a big use case is to have a single ingress controller in an underlying cluster, and tenants being able to create ingress resources without having to have a separate ingress controller in each virtual cluster. So there's an option to do that as well. And then nodes is an interesting thing that you can configure, because the question is, inside the virtual cluster, do you see a node? Where is this pod running, right? What do I see? Do I actually get information about that node where it's running on? There's a lot of configuration options you can do there. But all these higher level resources are not being synced. So the whole replica controlled resources, stateful sets, deployments, all of that stuff is not being synced. Daemon sets, same thing. And then not mounted or not yet mounted config maps and secrets, service accounts, jobs, there's a lot of things that Kubernetes actually has. So that right list looks similarly in terms of length than the left list, right? But the right-hand side is a lot bigger than the left-hand side if you're thinking about it. Because the right-hand side, especially with that last point, custom resources, right? Well, that's pretty much anything else in Kubernetes, right? Any custom provider, everything that Rancher does, everything that the OpenShift folks do is essentially custom resources. So that's the vast majority of objects that only live in the state of the virtual cluster. And we see that only very few resources actually need to be synced to the underlying cluster, or the status needs to be synced back to the virtual cluster. And that means we can also have different distros inside the virtual cluster. We can have different Kubernetes versions, alpha and beta flags. The controller manager could something different, right? All of these things could be different. The only thing that the two clusters need to agree on is the spec for pod, right? The spec for service, and the spec for certain resources that you may want to mount, right? Like a secret and a config map, for example. But those are very, very basic Kubernetes resources, right? Agreeing on something like the cert manager CRDs is a lot harder than to agree on the pod spec, right? Which is such a trivial resource, and hopefully we're not going to have any breaking changes in the pod spec anytime soon. Yeah, there's a lot of things you can do with virtual cluster. As I said, pod networking is working just as you would expect it. So you can do pod-to-pod communication via IP. You can pod-to service communication via regular cluster internal IP addresses, just as you would expect it inside the virtual cluster. Yeah, we're adding the DNS config. That's still the case, right? In vCluster is actually changing so quickly to the pod spec, so you actually don't have to do anything about this. We're launching inside the virtual cluster a separate cluster internal DNS, which you will also see as a pod. That means you could even technically, customize that, but we hook it up in a way that it just works as expected. And then again, ingress sync is something optional. In terms of nodes, pretty interesting. The answer is it depends. What you would see when you run kubectl get nodes. You could see fake nodes. That's actually our default. By default, we would show you nodes from the underlying cluster, but we would change their names and their spec and stuff like that. So you don't actually see the real node, but you do see a node, right, where your pod got scheduled on. But the underlying cluster could have 1,000 nodes, and you only see 3 because your pods are only running on 3 of these nodes, right? And where they're being scheduled to, well, that logic is defined in the underlying cluster, because your underlying cluster could still have admission control and stuff like that, and could actually, mutate your pods that get synced down to enforce certain, node selectors and stuff like that. Another option would be to see real nodes. That means we would just copy the nodes inside the virtual cluster without modifying them and obfuscating them. You could also enable that everybody sees all real nodes inside the virtual cluster. And there's a couple of other things that you can do using label selectors and stuff like that. There's also the concept of adding like fake virtual nodes and stuff like that, and mapping, like 3 virtual nodes to a real node and stuff like that. There's a lot of things that you can think about in vCluster now. It opens up a lot of possibilities, and we have a couple of flags that allow this. And there's a couple of crazy things that you can do as well. yeah, let's skip that for a second. Yeah, you can, Fabian, that's actually already working, right? I should remove the upcoming from here. So a lot of sync has already implemented. Non-root vCluster is also working, right? Yeah, so checkboxes behind everything upcoming here. We did a lot of work in the past, like 10 months or so since I gave this talk at KubeCon. Yeah, the last thing in this list, pretty interesting, nested virtual clusters. Actually, Rich gave a really good talk about this, or a really good like YouTube session about this. You can find it on Twitter and YouTube, where I did the session vCluster Inception, you know, like the movie, you go deeper and deeper, and how deep can you go? It's pretty interesting. We actually haven't run the experiment. Can we go like 500 times or so? But we should totally do that. Oh, it was just one. Got it. Yeah, so that's an interesting challenge, maybe for a next meetup. But I'm going to hand over to Fabian, who's actually going to show you some hands-on stuff with vCluster in how that works when you're actually opening this up in the terminal and experiment with this without just the theoretical level.
Perfect. Thanks, Lukas. Hey, everybody. Yeah, like Lukas said, I'm Fabian. I'm the CTO of Loft Labs, and yeah, I was deeply involved with creating vCluster. So I will show you now a little bit of like how you would actually use this. And I will do this for like, let's say, local development in a Docker desktop cluster. So when we take a look at the cluster, we would see, so K is an alias for kubectl. And this is like a regular Docker desktop off-the-shelf empty cluster. Nothing is running inside there. And like the goal is now to create a virtual cluster inside that. What we have is like a CLI tool called vCluster. And here you can just like create and then any name. For now, we can choose test. And what happens then in the background is essentially that this command is deploying a Helm chart, which essentially creates this small vCluster in a namespace called vCluster test, and deploys this stateful set, as Lukas said before in his talk. It also exchanges the kube context for us. So when we run kget ns again, we see exactly the same as before, but if you look closely, you will see the age is different now. And this means it's a new cluster. So when I take a look here with K version, I will see this is now on the server version, actually in K3S cluster, while before in the Docker desktop, it's a regular without specified version. So and if you take a look inside, so I'm back in the Docker desktop cluster now. You see there's a new namespace where the actual vCluster is now running in. And if I take a look at what's actually running in there, I'll see there's not much running in there besides 2 pods. So one pod, which is the test-0, that's the actual vCluster. That contains essentially 2 containers. One is K3S itself, and one is the syncer Lukas talked about. And then we have Crd DNS running, which essentially sets up the internal vCluster, Crd DNS, and networking. So when I take a closer look at the pod here, I'll see, there are the 2 container statuses. So this is essentially the syncer, and this is K3S. So it's like a regular K3S binary. It's not changed by us in any way. The only thing we are doing is we are disabling a bunch of stuff. Like Lukas said, for example, the scheduler, the agent, certain like default deployments they do as well, because we don't need that, because we are now reusing a lot of things from Docker desktop cluster itself. We don't need to deploy another network plugin anymore. So we only need the real control plane of that. So the question is now, why do you need this? And what's really cool now is when I connect to that cluster again, which is essentially just exchanging like what my kube context points to. So I'm now in the virtual cluster. I can deploy, let's say, cert manager inside that virtual cluster. So I deploy cert manager. It creates a whole bunch of stuff. What we are especially interested in are the CRDs. So we now have things like cluster issuers, certificates, certificate requests, and so on. Those now only exist inside the virtual cluster. So when I go back and I do CRDs, we don't have any CRDs. It's only living inside the virtual cluster. And when I get pods, I see there are no pods in any cert manager namespace or anything. There are only pods by Docker Desktop inside the kube system, and there are pods inside the virtual cluster namespace. So vCluster makes sure everything that's scheduled within vCluster, no matter the namespace, is actually scheduled in its own namespace, which makes it really easy to isolate that namespace as well, because you can use regular resource quota, network policies, and so on. And inside the virtual cluster, you can now use those CRDs. So for example, you could also think about having multiple different vClusters, installing multiple different cert manager versions or different operators, and so on. All that is easily possible. So when I do, for example, here an apply of, an issuer here, issuer.yaml. Second, it's in the vCluster demo namespace, sorry. Sorry? Oh yeah, the O is missing. Yeah, so the issuer is now created. We can also create a certificate that belongs to that, just to show that it's really working and not some sort of fake CRDs. And then we can do get certificates. We see this is like a self-signed issuer for cert manager, and it's a certificate that just creates essentially a small self-signed certificate in the cluster. Nothing fancy, just to show that it's working. And you essentially see, hey, there is a secret created out of the certificate inside the cluster. You can even go in there and say like, hey, let's do something more fancy. Let's install Argo Cd inside the virtual cluster. There's a whole lot of other stuff created as well. But since vCluster, and that is like really one ambition of us, it should feel like a real cluster. Everything that works in a regular cluster should work in a vCluster. So we have people that essentially develop Istio with vClusters and shut them down and essentially spin them up just to testing different Istio versions on a single Kubernetes cluster. So when I do this now, I just retrieve the Argo Cd password. All of the Argo Cd pods are already running inside the virtual cluster. I can do pod forwarding to the Argo Cd instance, and then essentially use this password here to log into into Argo Cd through the local web browser. And this is now purely running inside the virtual cluster. And the cool thing about virtual cluster is not only that you now can install multiple like different CRDs into like the cluster, you can also pause it and resume it later. So let's say I want to work on a different project. I have my setup in this virtual cluster, which involves a couple of operators, CRDs, and whatever. You say, hey, I pause this cluster now. vCluster makes sure everything is essentially like scraped and deleted. So there are no more pods running after this command went through. So like essentially space is freed up for other resources. So when you do a PO here in the, you see there's some stuff still terminating, but besides that, you have only the kube system pods running left. And then you can create a new vCluster, for example, I don't know, test2 or anything, and work on that. Then even delete that or pause it again. And when you need to work on that other project again, you can just resume the other project. So this is like still spinning up. But meanwhile, we can then say, hey, I want to work on the other project again. vCluster is recognizing, hey, this was a paused vCluster, it's resuming it. And since like the state of this vCluster is fully saved inside this virtual control plane, we can now completely spin it up again with just a single command. And like after a couple of seconds, everything we've installed beforehand is now running again. So this is really like a quick overview of what vCluster can do. It's more or less a terminal demo. We also have now a very nice UI for vCluster in Docker Desktop itself, which we've created through this Docker extension, which Lian will demo soon. But yeah, I've showed you a little bit like what's the current or what you can do locally with just vCluster CLI. Yeah, cool. That's
awesome.
Thank you.
Yeah, we're gonna have a little. Oh, you have questions? Go for it.
Do you have compatibility constraints in version of the virtual cluster and the main cluster?
Can you repeat the question? So that
Yeah. So the question is, do we have constraints regarding the version between the host cluster and the virtual cluster, right? If there needs to be any compatibility, essentially, right?
Depends. Let's call it, this depends a little bit on the versions themselves. Let's call it like this. So there are certain things that could be breaking. So for example, one change that was breaking, which is not working correctly, is, for example, if you try to sync ingresses, and there is like the one in the networking API group not there anymore, you can obviously also not sync it into the host cluster because it does not exist above, I think, 121. Or 122, I think. And but there are other versions and other resources where this like doesn't matter as much. So for example, if you're like using pods is a very stable resource. There are no breaking changes at all. So you can even use like a host cluster version 116 or 117 and a virtual cluster with 124. So that's totally possible. As long as you're not colliding on any resource that you want to sync. And like Lukas said, most of our resources that actually sync is also like turn on, turn off. So if you find out, hey, this resource is making problems, and for ingresses, it's more or less optional to sync those, you can just turn them off, and it would also work across like a higher difference between versions.
Yeah, I think that was very rare that actually, a resource that we had by default enabled changed. I think it was like 124 or so when they made that change.
Yeah. But like usually, since like vCluster really only syncs the core resources, which is like services, secrets, pods, maybe persistent volume claims as well. But those almost never change anymore. Like they are very, very stable. So usually you can just use a different version inside the vCluster than inside the host cluster. What doesn't work if they add features in a new Kubernetes version, for like example a pod, so ephemeral containers is a fairly new feature. So you wouldn't be able to use that feature inside vCluster if it's not supported in the host cluster, since we are like reusing essentially like computing and networking of the host cluster. If it's a pure control plane feature, then it would work in the virtual cluster.
Yeah, I think the ingress change was a pure spec change in a way, right? Just the API group basically changed and a few minor things. I think we could have actually implemented logic in the syncer to say like, if this version is smaller, then convert it like this. We didn't really do that, but I think
Yeah, there
We
are
do that in some places.
there are
In some
always
places we do
workarounds
that.
as well. Yeah.
Yeah, so tell the SIGs, no breaking changes.
Yeah. Any other questions while we're at it?
The virtual clusters, how should we think about resiliency when it comes to the physical clusters? Is there a way to set it up where you can deal with the physical clusters going down without the virtual clusters?
Oh, that's a good question. That depends.
let me repeat the question.
Oh, sorry.
real quick.
I'm
Just-
sorry.
Yeah, because the stream, we always need to repeat it so people on YouTube can follow along. So the question was essentially regarding resilience and what can you do to improve resilience of the virtual cluster and of the underlying cluster. We're running virtual cluster in there, right?
Yeah, so since the virtual, I mean, it depends here as well, because it depends on like what's malfunctioning on the host cluster. So since we are now duplicating certain parts of Kubernetes, like the control plane, parts of the host cluster control plane could actually be down and the V cluster would still be working. But this really depends. Like if the host cluster, for example, nodes where V cluster itself is running on, for example, crashing, then V cluster itself would also crash. So it really depends, like what is malfunctioning on the host cluster, and then this can have an effect on V cluster. But in general, since it's like separate endpoints where you like reach the API server, V cluster is also like very good in taking off load from the multi-tenant shared control plane, because you have now different endpoints. And I mean, in Kubernetes, there's this concept of API priority and fairness. But with V clusters, you actually don't need that anymore, because you have separate endpoints where your users are going or accessing Kubernetes. And if you spam a Kubernetes API server or like a V cluster, and that goes down because of the load, it has no impact on the host cluster, because like the API server of V cluster is handling all those requests.
Yeah,
I think I think that's all the time that we have for questions.
Oh, sorry.
No, it's okay. Let me grab one of these real quick so I can talk to the folks on the stream. Thank you for the questions. We'll be around like for a little bit afterwards too, if people want to ask more questions, or you can always find us on Twitter or in our Loft community Slack. We're just going to take a really quick like 10-minute break here. And then Leanne is going to do a demo of our new extension for Docker Desktop. And Mike is going to give a talk about some cool stuff that they're doing with vCluster where he works. So those should be a lot of fun. Let's just call it like 10 minutes. Let's say 6:50, we'll get started again. And thanks.
should be next time Dr. Desktop pushes an update to everybody.
Okay, so the reply to this just. Oh, okay. So you can use it from tomorrow on, I guess. Okay, cool. That's it. Thank you very much. And I will hand over to the next speaker, who is coming here.
Great. Thank you, Leanne.
You're very welcome.
If you could give Mike your
I will give Mike my mic.
So next up is Mike. He's going to just take a minute and get wired up, but he is one of the folks from Adobe. He's been doing a lot of really cool stuff with vCluster. We haven't seen this talk yet. I'm really excited to see it, to get an idea of what they've been doing. It's been really fun for us to like hear the stories from customers about how they're using the tools and what they're doing. So if you do end up playing around with vCluster and you end up using it, whether it's like in your own infrastructure or for local development, or we've even talked to people who are like using it to build their own tools, right? Like their commercial products, vCluster is part of the product. We would love to hear those kinds of stories. And so you can find us, we're the Loft under SH at Twitter, or I'm just Rich Burrows at Twitter. And we would absolutely love to hear those stories. Okay, Mike Tougeron is here to talk to you about some cool stuff.
All right, so so this is me. I'm Mike Tougeron. I'm a lead cloud engineer at Adobe. I work on Adobe's, we call it the Ethos platform. It's basically our Kubernetes installation. Should have been. Let me share again.
Yeah. Thank you.
Sorry. All right. Is it sharing now? All right. All right. So Ethos is our Kubernetes installation at Adobe. It's a pretty vanilla installation. It's very much based upon kubeadmin, so it's not like it's anything that fancy. It's just got our business logic on top, but it is a pretty big install. We got about 210 clusters across AWS, Azure, data center, 22 regions, 14,000 nodes, 1.3 petabytes of memory, 400,000. You can see all the stuff up there. Obviously, with all of that, cost is a big factor. That's a really expensive set of clusters to run. So some of the problems we're facing, mentioned cost, that's really big. We're a multi-tenant cluster, so controls around that can be a really big pain in the, put a word in there, it's up to you. The sum of the whole of API calls can really hurt our API servers and etcd servers much more than individual calls. So one tenant may not be doing that much, two tenants may not be doing that much on their own, but you take a dozen tenants, 3 dozen tenants, so on, all of a sudden the sum of all of that really make a big deal. Custom operators are a really big deal to us. Tenants want to run what they want to run, but that's a pain to manage on a namespace basis versus cluster-wide. And everybody wants more control over their systems, and it's really hard to give that in a multi-tenant environment. So why do I care about vCluster? I mentioned the cost efficiency stuff. I'm going to speed up a little bit just because we are running behind. Security is really cool. We can give API access while still keeping host cluster control. Our pod security policies are still in effect. Network policies are still in effect. We can still run OPA, have things like you can't schedule onto the control plane nodes. That's really huge for us. You can't run, the pod security policies. You can't, have host paths, stuff like that. That's really cool. You can also have much more flexible RBAC. So you have the multi-tenant RBAC on the host cluster, but inside the vCluster, the tenants can basically do whatever RBAC they want on it. It's also highly dynamic. Clusters are cattle. They're no longer pets. Provisioned and destroyed on a whim, and we'll see a little bit of that in a moment. So the cluster API, if you're not familiar with this project, I highly suggest checking it out. It's a really cool way to declaratively create Kubernetes clusters. It's basically an operator that runs inside of a cluster, takes a manifest, builds Kubernetes infrastructure for you on a cloud provider. Has a lot of plugins. What's really cool is there is a vCluster provider. So thank you very much. I know Fabian's done a lot of work on that, so that's been really cool. Again, I highly recommend checking out this tool. I've been really fascinated by it for the last couple of months. The glue for all of this together for this talk is Argo Cd. I don't know how many of you are familiar with that tool. Hopefully a lot of you. It's a really powerful tool in the GitOps ecosystem. You can do automatic deployments using Helm, customized JSONette. It's got a big ecosystem with things like Argo rollouts, Argo workflows, Argo events, Argo blah, 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 blah. There's a lot to it. But what's really cool with it is you can do automatic deployments based on things like a PR. So not just what manifests are in a Git repo, but when a PR is opened up against a Git repo, I can do a deployment, which is really cool. So all that together, let's get to the really interesting part. Let's do a demo. So what I have here is I have an Argo CD installation. So very simple. Right now I have 3 vClusters connected to it. Not that interesting, right? Well, maybe it is because we got vClusters connected into Argo. Woohoo! But what I have here is I have a Git repo, and there'll be links to this in the slides at the end. But basically this repo is set up with a webhook that basically goes and hits that Argo installation whenever there's a PR. So let's go ahead and make a change. So I am going to try and click on this here. So what I'm going to do is I'm going to come down here and I'm going to say, oh, I have a typo in my manifest here. I have a dash, dash, dash here, but I'm missing it in my else statement. Okay. So let's go to my code and I'm going to create a new branch, fix manifest. All right. And I'm going to go ahead and put that in real easily. So git commit am fix bug. I did it as a branch. Okay, good. /u origin fix manifest. So we're going to hit create pull request. We go back over to Argo here. All of a sudden, a new tile showed up. And how this works is what this is doing is this is going to go ahead and create a cluster using a vCluster cluster using the cluster API. So the way that this works, oops, wrong button, is using an Argo CD application set. And what that says is for every pull request to that repo, go to this repo, pass in these parameters to that Helm chart, plug it into this namespace on this cluster, and run that Helm chart. So what does that Helm chart do? Well, that Helm chart is right here. And what that does is that creates a cluster API resource called a cluster with the cluster name. And that infrastructure reference says the type of infrastructure I'm creating is a vCluster. That vCluster right here, here I am. I'm creating a cluster API reference of vCluster. You've heard people mention before, vCluster installs Helm charts to go ahead and create its things inside of the namespaces. Well, here's the vCluster stuff that gets set up, or the Helm charts that get set up for vCluster. So that's all in there. You can specify the control plane endpoints for how you want to connect into your vCluster. And then that's all we're going to go over for at the moment. So if I come back and I run part of the thing that you can do, which is really cool, whoops, kubectl get clusters and vCluster, is we can see the cluster. I'm going to sit down, so let's do this. We can see that the cluster API is now provisioning a new vCluster environment right here. So if we were to say vCluster list-n vCluster, we'll see that vCluster is also seeing that there's vClusters listed in that namespace. So the vCluster cluster API provider is automatically provisioning this without me having to run the vCluster CLI. It's all being done declaratively by the Kubernetes API. So why is this there? What else can I do with it? Well, I can run, well, let's see if that's, okay, it's now provisioned. I thought it should be done by now. All right, so I can run cluster ctl get kubeconfig vCluster. I can do this without a mouse on here, I promise. Get kubeconfig. And here's a kubeconfig I could use to connect to that vCluster. So I could connect to it in the standard way that I'm used to with a kubeconfig instead of having to use another CLI that I may not have installed on my system. So I've had to install the cluster CTL config, right? But this exists as a secret inside the namespace. So I could just download this secret, export it as a file, and have that secret and use that kubeconfig. Much in the same way that the vCluster works, but it's there. So one of the things that you'll notice is that I've set it up with an ingress. So I can now hit it without having to use, again, my local proxy or anything like that. It's now accessible via the internet. Now, it's not publicly accessible on the internet because it's locked down to my VPN, but you get the point. So if I pipe this to PR11 or kubeconfig config-pr11.yaml, and I export my kubeconfig-pr11, I can say kubectl get pods-a. And we'll see I have just the core DNS pod, just like everybody's been showing you before. I now all of a sudden have this vCluster, but I didn't really have to do anything to do that. It all happened automatically when I created my PR as part of my code build process. So all of a sudden now, as a developer, I can have a dynamic Kubernetes environment for my application when I'm developing code. So if I'm writing a custom operator, I can now do this development live on a Kubernetes cluster inside of a virtualized cluster without having to impact anybody else in this virtual multi-tenant environment. So why do I care about this? So I'm not going to bother zooming in on this. Because people work on pieces of the application most of the time, not the whole thing. So being able to tie it into Argo Cd, with these PRs, you're able to not just create an environment, you're able to now tie it into that Argo and do a deployment of the rest of your infrastructure to sync things down. We saw within here, I have other deployments going to vClusters. So vCluster now is part of my Argo Cd deployment. So my core CRDs are deployed automatically to these vClusters that are there. The developers don't have to worry about installing these core pieces of infrastructure. You can hook this up to something where the Argo process kicks into an Argo workflow, automatically adds it back into Argo Cd, and the default CRDs are installed onto the PR's server. So the developer's application code now has access to all the resources that they may have had as part of a standard server development, standard server deployment without having to do any additional work. It's all automated for them as part of that PR process. All of a sudden, your infrastructure, your developers are no longer saying, hey, ops team, or hey, DevOps team, or hey, SRE team, provision me an environment. It's just done for them. Very powerful functionality. One of our biggest challenges is the CRD development. Somebody wants to update Prometheus operator. Somebody wants to update any sort of custom operator in a multi-tenant environment. You can't just do that testing without potentially breaking someone else. Now they can. They can open up that PR. They can open up that vCluster environment. But even more than that, applications can be written poorly. They can impact other applications when they interact with the API server. So what does that mean? Remember how we were talking about the sum of the whole can make a big difference. So let's talk about that a little bit. We have a situation where an application creates tens of thousands of secrets and thousands of config maps on a cluster. I don't know if you've ever had to do that before. I hear people laughing. I don't know if it's because you can just imagine or if you've actually had to deal with it. But that uses up a lot of memory on your etcd nodes. It uses up a lot of memory on your API nodes, and it uses up a lot of CPU space. Not only that, it's resource intensive on API calls. So we have this tool called Watchy. It's written by a coworker of mine, Evan Foster. And so this is one of the things where we use to simulate bad code that developers have written. Yes, this is a real world situation. And this is where this vCluster environment has come in really handy for us with these teams being able to test their code. So let's see what actually happens in that vCluster environment. So let's go with this. So I've installed, whoops. Let's switch my kubeconfig back to the default. So CTX, VC, cluster A. All right, kubectl get secrets in the default namespace. So let's do a time on that, just to see how long that takes. Well, that actually was really long. There we go, that's more appropriate. There's like no secrets there at all, right? But we have this application called Watchy on here. Let's create some secrets. So coming back to here, let's create 10,000 secrets. So as we have talked about, if I were to do a kubectl or a time kubectl get secrets on all namespaces on what do I call it, TG Azure, on an Azure cluster, on the host cluster, and let's just pipe that to dev null just because I don't want to show what all I got. It took just a little bit of time. And let's get actually a count of them, probably 314 of them. All right. So let's create those secrets. So 10,000 is not much for this cluster. What's that? Yep, it's spewing out a whole bunch of secrets. Takes a couple seconds because it is 10,000 secrets. All right, so let's go back and get the number of how long does it take to get the secrets in the default namespace on that vCluster again. Remember when we first ran it, it only took a fraction of time. Just fraction of a second. All of a sudden now, that took 3 seconds. That's a little bit of time. If a developer, did this on a cluster that other developers were using, they're going to get impacted. People are going to be like, why is the API server so darn slow when I try to get my secrets? What's going on here? But if I do it still on my host cluster, I still don't get that kind of response time. I'm still getting sub-second responses because, as Lukas had mentioned earlier, it doesn't sync secrets unless it's being used by a pod that's mounting them. In our case, the application reads the secrets directly from the Kubernetes API server because it's not going to mount 10,000 secrets into its 200 pods. It uses them as more of a store inside the Kubernetes. All right, well, that's great, but let's make this more real-world-ish. Yes, real-world-ish is closer to 50, 60,000 secrets. So we're going to go ahead and do this, and I'm going to talk about it a little more as just kill some time as it creates 50,000 secrets. But what's going to happen here, we're going to see in a little bit, is this is going to fail. And why is this going to fail? Well, it's because it's going to OOM the etcd server. But that's not that interesting while we're waiting for that, because it's just not that interesting. What is interesting, if I do this against the host server, and this was mentioned briefly earlier, I'm purposely running an older version of Kubernetes here. My server is 1.21.11, right? But if I run this against VC cluster C, whoops, wrong one. This is actually the wrong one. Export, I meant to run on this one before we made the switch. Well, I thought I set this up differently. I thought I had changed this to be 1.22, but apparently I didn't. The point of that was to show that you can run the different versions without compatibility issues. But I think we had discussed that a little bit earlier as well. Darn it, now this is bugging me. Now I got to just try to see if cluster B or C has it. No? Well, you know, whatever. Not that big of a deal. You can see, though, I am running multiple clusters of different types all in the same namespace. It's still running, hey, it crashed, failed to create. That's not a good thing, right? So if I'm doing this here, all of a sudden my V cluster has blown up. Things are not working right on it, but my host cluster is still totally fine. If I were to run the time again on it, I get back my data totally in an appropriate period of time. If I try to run it all against the V cluster, I don't know. I don't know what I'm getting back here. Things are screwed up. So again, here, we're back to the whole idea that our developers who are screwing things up, they're just screwing up themselves. They're not screwing up everybody else. 19 seconds. Who loves those sort of API response times with where they're going? So this is why we're playing around with vCluster at Adobe. It gives us that isolation. It allows us to have these teams that use a high volume of traffic against the API servers. Gives us that isolation, allows them to do what they want, and they're only going to screw up themselves. So how are we doing on time here? I kind of sped this up a bit just because I know. Yeah, that's what I was trying to speed up a little bit there for. So I kind of skipped over some stuff with it. We got the last slide here just to show the contact stuff. How do I get to that? Where's the next slide? Come on. Go, PowerPoint, go. Subtitles are not what I wanted. There we go. All right, so there's how you can get to the, where you want the info, all the links to the different tools that I use, the link to the repo. It does have all the steps in much more detail. I will put the PowerPoint slides up there, the links to this, but all the code, including how to use watching, how to launch up a cluster using Cluster API, how to launch up a V cluster, doing PRs, installing Argo Cd, the whole works. It's all there step by step. So thank you very much. Thank you, Loft, for having me out.
Mike, that was really great. Apologies that we were running so late and you had to blaze through that, but we really appreciated seeing that. Definitely check out the slides. I'm interested to dig into some of this stuff. Because we are running late, we only have the space till 7:30, so we're going to need to wrap up. There's no time for questions for Mike, but you saw his Twitter on there. Feel free to hit him up there, or grab him here if you can before we go. But I want to thank everybody for coming to our first meetup. It was really great to see all of you folks, and we will be doing another one again at some point, maybe within the next few months. So probably the best thing to do would be to follow us at Loft under SH on Twitter, and we'll be posting announcements about that. And that's it. And for the folks on the live stream, thanks so much for sticking around. Appreciate you bearing with some of our audio difficulties and things. Yeah, have a good night.